Yeah, that's cool. That's cool. That's what I like to see. Today, we are going to build an AI memory code layer. So let me tell you what high level problem is. Imagine you get multiple chats. Every chat doesn't know about each other, right? So every time you create a new chat, the AI memory is essentially new. So how I'm thinking through sort of memory is that memory works like this. When you look at a human memory, it has two different types of functions. Save, right? Then there is recall. And neural networks, which are the basis of AI, they are based on how humans work, how human brains learn, and how neurons activate, etc. And so I was thinking, if I learn how human memory works, then maybe I could potentially create something cool here. So despite the article being extremely interesting, I didn't find anything useful that I could use. Turns out human memory is much more complicated. Now, thinking through the project, it turns out to be way more difficult. So I had to type down everything that I need to figure out. The first one was how to decide whether something is worth to remember, because we cannot really just remember every single thing because there will be too much data. Then there's quality, like how do we actually measure whether our system works good? When to recall? Do we do that at the start of a chat? And what to recall exactly? Are we doing semantic, which means the meaning, or keyword, which means how many keywords are matching? Maybe the plan will be like this: get some MVP out. So essentially build anything. The second thing would be to prepare validation. So I'm going to first do the MVP. I don't know why LLMs tend to do this, but instead of installing dependencies, they write fucking JSON with dependencies, like with some very weird versions, which I don't understand it. Let's see how it works. High level. So it saves the memory. Okay, it takes so saves text, and text will be the last. Yeah, it's effectively, we are taking first the parameters which are run and this and, this and this. Then the memory will be a string. We use bound for the CLI. Okay. This is ugly as okay, this is interesting. Yeah, let him. Oh my god! Like I love how he does this shit. Like the weirder it looks, like it's getting more crazy. I want to remember how my dog is named. His name is Frank. So I want to remember that. Let's see whether he calls. Yeah, nice. And look at this. Hey, what's my dog's name? Yeah, that's cool. That's cool. That's what I like to see. You can see he remembered the name of my dog. This is very useful in here. Now, this is first of all, super simple, like very useful, right? But we want to have it more complex down the road, because what we will do is the same thing that our memory does. So think about our memory. Like we are not remembering everything, because if we would do it, we would, after 2 hours, have absolutely full brains. Like imagine you remember everything. Like it's impossible. So our brain has to only remember things that are important to us. So the ones that we pay attention to. So for example, I'm not going to remember that there is a console log save. Which, by the way, I'm going to remove those console logs here because they are stupid. I've made a video about coding rules, and it's actually going fine because look, he didn't even like add another library. He just created his own math, which is very nice. It's obviously shitty. However, I like that he didn't create too much code. He actually created only necessary code, which is just calculating cosine similarity. he didn't need anything else really. Like this tool is so simple. Validation. Now, this one was extremely hard because I needed to figure out what are some cases for testing memory. So I needed to create real life scenarios of just programming with AI that could be helpful for this particular use case. And if I say something like this, in this repository, we only use like camel case, right? Now, this is a very important and common case in like working with agents. When I tell AI it, right, it's not going to remember in another chat window unless I create a rule that specifies, hey, in this repository, we only use camel case. But if I have memory, AI should automatically save memory as here we are only using camel case. But now it's simple to think through memories on save, but how will we retrieve it, right? So would we retrieve it every time, or should memory work something like this? So here I've actually struggled a lot with figuring out the next step. And so what I've decided to do is try to take this problem from first principles. So ask myself a question like, what kind of problem does this memory layer solve? Conceptually, something like this. And here we might have something like human, for example, this is an expertise. Maybe there's like programming, right? Which would be one expertise. Another might be like sports or something like that. Another might be, for example, video games or whatever. So all of these, and here you can imagine this is just one giant concept, but then we are having many smaller ones, like maybe variables, whatever. Like there are like, you can imagine I think they go like multiple levels deep. Like this is how expertise is sort of stored. This is how I imagine this being, right? Maybe variables, what's a high level before programming? Let's say there's like debugging might be one skill. And then within debugging, you might have, maybe there's also like, think for this otherwise, like debugging is what one of the things can be reviewing code, which is a different skill than writing. So for example, writing could be here. And then inside reviewing code, we might have, or maybe inside writing code, we might have something like, I don't know, like security or something. Now, because security, it's not really, it's a skill that gets opened when writing code gets sort of stored in the brain, but it's also a completely separate area of expertise. Yeah, so that's interesting, right? I need to also think through how, I really like to think through shit like this. It's so much fun. Security, then there is like, and within security, you might have, let's say, I don't know, fucking pen testing or whatever. So you can imagine this is how I would imagine memory works. Let me actually put you on a game right now, or with AI, and we came up with like, however you want to say it, but this is an interesting concept that I would need to try in the following versions of the project. So you can think about like, now the most interesting part is the last one, but let me go through each one. So if you think about our memory, we always remember roughly what happened, right? You cannot recall everything that happened. For example, like today, I know I ate breakfast, I went running, I was like playing some music, whatever. But I know what I learned, which means that like the most important stuff, for example, things that happen at my job, like a new project, like a new caching module that I've learned at my job, which would be semantic memory. Now, for procedural memory, specific things that just humans tell AI. So essentially, please do this, right? It would be like some type of, we need a way to extract, okay, maybe I can note it as well. We need a way to extract information about, extract rules. So essentially rules will be, let's say a human says something like this. Hey, I want you to write all variables camel case. I want AI to remember that the user wants variables camel case. Next time AI writes variables, all variables camel case, but user says, hey, no, I actually want only changeable variables camel case. Then we need to also adjust this. Now, this is where the fifth step comes in. Now, the fourth, okay, let me go back to the first step for a second, because I got a little bit ahead of myself. But so the entity relationship graph means that essentially, if you think about memory, as I've sort of drawn it here, everything is connected to each other, right? There is like high-level programming skills, which under that goes debugging, reviewing code, writing code. But for example, security skill might also be triggered when writing and reviewing code as well. But this is a separate skill that also has, like, for example, pen testing or like web vulnerabilities, like SQL injection, etc. All of these things that you know. Now, the memory consolidation is really what I wanted to talk about at the start, because this is the most interesting part. I wasn't really happy with how I explained number 5. And I think this concept was the most interesting one, because this is the one that we can take from the human brain. We don't fully learn while being awake. We also learn while sleep. When we sleep, our brain creates new connections between our old skills and new skills. And sometimes we tend to understand things on a deeper level when we wake up compared to when we are learning them awake. And I think this is extremely interesting in the case of this project, because here I will try to also, as a background job, consolidate memories to not overflow our code brain.